button.
Webinar is now live.
Cool, cool. Awesome.
I feel like we need some elevator music.
Mapbox has a theme song. This is the time.
Steven, when I'm in CodePen, does it automatically fork if I start making edits to the repo? I'm not seeing like exactly where to fork.
So along the bottom, I think at the bottom right, let me pull up that window again.
I see it. Thank you.
Yeah, it definitely used to be way more obvious. I'm pretty sure they had it in the top nav bar.
Like not this tiny thing down here. But great. Yep. Forked a minute.
Cool.
To all the attendees who are kind of trickling in, we're gonna start in 5 minutes, but I think right now we're gonna make a check-in code real quick so y'all can get some points from this event. And yeah, nice to have y'all join.
Yeah, welcome everybody. Feel free to ask questions in the Q&A during the session, and I'll do my best to either answer those as best as I can while typing, or maybe like pause Stephen for a second while we're presenting. While we're still waiting for folks to join, if you want to just let us know if you've ever used Mapbox before, or if you've ever seen our maps before, or what you're interested in mapping in general, that'd be cool.
Yeah, as Megan just mentioned there in the chat, if you haven't already created a Mapbox account, you can sign up for free at account.mapbox.com. We're gonna reshare all the links that you see in the presentation today. So it's gonna include like examples of our customers, some demos, and the tutorial that we're gonna be going through at the end of the session. So you can kind of get your hands dirty with Mapbox, understand how it works a little bit behind the scenes and how you can add it to your applications. Give one more minute and then jump into things. Okay. ACM team, all good to get started? Move ahead?
Yeah, yep.
Okay, awesome. So welcome everyone. I'm gonna present here and almost changed presenting access. I just wanted to present my screen. So there we go. Megan, let me know that you're able to see that. Okay, cool. So yeah, again, thanks everyone for joining. My name's Steven. I'm a technical account manager and solutions engineer at Mapbox. And Megan here with me.
Hi all, my name's Megan Danielson. I'm a community program manager at Mapbox.
So in case you haven't heard about Mapbox before, we're going to go through what Mapbox is and what we do, who works with us, but we're going to drop in a quick plug for a community team that Megan helps lead out.
Yeah. So the community team at Mapbox, we support nonprofits, educational institutions, which is how we got hooked up with ACM, and positive impact projects. And we support all of those different institutions and organizations in a number of different ways. We provide mentorships and skilled volunteering opportunities, both internally within the company and then externally to help our partners out. We also provide discounts and kind of like tailored payments for accounts that go over our free tier for educational use. Most of you all will always be within the free tier, but if for some reason you happen to go over it and it's still an education project, then you can contact the community team and we can help you out with some discounts. As well as we can enable some special features and permissions. So if you're hitting our geocoding limits or any of our API limitations, we can help adjust those or raise those based on your specific project. And then another part of our job, what we do is we love to promote what our community partners are doing, what our education partners are doing. So we're constantly writing up blog posts about everybody's projects that they're contributing or sending out things through Twitter and stuff like that. So if you have a project and you need help with any of the things that I just mentioned, please feel free to reach out at community@mapbox.com.
Awesome, thanks, Megan. So Mapbox at its heart is a mapping and navigation platform. If you haven't worked with any location platforms or any location or geospatial tools before, it can be a little intimidating. It's a very like niche kind of, it seems like a niche space when you first encounter it, but it's actually pretty ubiquitous to a lot of different industries, types of organizations, solving different problems. So today we're going to go through what Mapbox is, what it isn't, and how to get started with it. So it's probably easier to start off with explaining what it's not. So we're not a consumer app company. We're not out there publishing applications to the like Google Play Store or iOS App Store or Mac, Windows, all that. And we're also not a GIS software. So if you've heard of GIS software, it's usually associated with companies like Esri or ones that are used for like very specific geo analysis. And that's not what we are either. We're what we call a location platform. So we're like the developer tools if you want to add some location context into your applications. So whether you're building for web, mobile, we have SDKs you can see here for iOS, Android, Unity. So you can really do cross-platform development there, and web development. I work mostly with a lot of our JavaScript library and our APIs. So not only can you use these across a bunch of different platforms, but you have a few sets of tools when you sign up for Mapbox. You can get mapping, which is probably the most obvious because of the name. You get search functionality. So if you ever wanted to add search, like a place search to your website or your application, we make it super easy to do that as well. And we have navigation tools. I'll go into some examples of actually how these can be implemented later. So this is Mapbox Studio, what you're seeing here. And Mapbox Studio, you can kind of think of it like a Photoshop or Illustrator for maps, or similar to Sketch. It lets you customize. It's a UI that when you sign up for your Mapbox account, you can jump right into. It lets you customize the data that's visible in the map, how it appears. Say you want to change the width of roads or the color of the land and water. You can literally change every layer of data. Not only that, but you can bring in your own data. And this is really what makes the platform so powerful. So in this example, somebody was bringing in some, I believe it was voter data, or
this is temperature data.
Or this was temperature data.
Yeah.
Not as timely as the voter data, but you can see how you can quickly use Studio to prototype out data visualizations, which is one use case for mapping. Now, if we continue on, I have a couple of customer examples that might help you connect the dots about how location is bigger than just like geo analysis software, things like that. So there are a couple of key industries that we play a pretty strong role in. First off, the logistics and mobility spaces are ones that I've worked with customers in a lot. So when you want to figure out how your drivers can get from point A to point B, you can use our navigation tools. When a customer needs to see where their package is and when it's going to arrive, right? That's all location context, just in different use cases. One particular example from this logistics slide. So right up here at the top, we have Optum. I worked with Optum when they were adopting Mapbox, and they have this tool for planning routes that drivers need to take. So, you know, a company would pay for Optum software, which has Mapbox tools built into it, so that they can make sure their drivers have the most optimal routes. If you've taken an algorithms course, you might have heard of like Dijkstra's algorithm, you know, search path algorithms. That's kind of the tooling that's behind the scenes, but we turn this into a simple API where you can pass in a couple of coordinates, you know, latitudes, longitudes, where those drop-offs and pickups are going to be, and we send you back the optimized route. And the API is scalable to, you know, you could make a call a day, you can make 100,000 calls a day, and you wouldn't notice any difference. It's kind of the benefit of having this platform tooling. Now, I guess it's worth noting, this uses both our navigation API and our mapping stack. You can see from the visuals. Some other industries that customers utilize Mapbox for are in social media and in retail, where they're reaching a lot of end consumers. So you are probably familiar with Snapchat or Facebook. Some of the ones on the bottom, Ring, Loco, right? They use Mapbox to create these very custom branded maps that their end users are going to identify as that brand, right? Rather than a Mapbox map. So if you've ever seen the Snapchat map or the Snap map, they use it to create this really kind of like cartoony, fun looking base map. They did a lot of that customization in Studio. You can see they brought in unique, you know, like patterns for the water, and they layer on user data on top where people have uploaded videos. We have a lot of customers in the outdoor space and the media space. So outdoor, if you've ever used Strava, for example, it's a running and cycling app. You can track where you ran or where you cycled. See your progress if you improve. Day after day or week after week. In the media, platforms like New York Times and Washington Post use this to map data a lot in their articles. This visual here, you can see how in Strava's mobile app, they help users with a very outdoorsy, rich oriented map. It has certain natural features like mountains called out, and they have elevation bands visualized. It helps people get the right context for this particular use case. We also work with a lot of BI customers and government customers. So there's a lot of BI tools, so including Power BI, Sumo Logic, and MicroStrategy here. You might be familiar with Tableau. There's a lot of platforms that want to marry this large-scale data processing, analysis, and visualization with very performant mapping and analysis. So we help those organizations, and I actually have the pleasure of working with a couple of our government customers. For example, here we have a map that FCC has public to show where broadband internet access is most accessible. Any questions in the chat yet, Megan? Good to keep moving along.
Yep, no questions. We're just talking about other industries that use mapping. And we did get a question, would the election industry be using location data to map out how certain communities vote? And oh, go ahead.
I was going to say, yeah, definitely. Actually, our community team has helped with some of those efforts on occasion. We've seen some really interesting articles out of media outlets that analyze, especially things around disenfranchisement. It's very, the visual tools aren't, it's not only the performance that's great, but the customization of the maps is what helps a lot of our end users tell a compelling story. Megan, were there any in particular this election cycle that come to mind for you?
Well, we used the isochrone API to look at the different. So in Texas, they had 12 drop-off ballot sites within Harris County, one of the largest. I think it's the third largest county.
Houston, right?
Yeah, in the U.S. And they went from 12 drop boxes to 1. So we used the isochrone API to kind of measure how far people can need to travel to get to this one drop box, as opposed to traveling to those 12 drop boxes. And I just posted a link in the chat to the blog post that we wrote about it. But yeah, location data is really critical and extremely difficult to get in terms of election data. You're talking about different geographic aggregations down to precinct level data and reporting. And folks at the New York Times, folks at the Wall Street Journal and stuff like that, they're collecting that really quickly and turning that into the maps like you're seeing here today for you to consume, to be able to stay up to date with what's going on.
Yeah, I forgot about that article. Yeah, that's a great example of how you can combine the different tools and then your own data or a third party source of data to come up with something that people have never seen in that same kind of light.
I just want to do a quick plug. We extended the deadline for our elections mapping challenge, and I'll post a link to that in the chat. And there are some cash prizes and the ability for you all to win just by creating a visualization using our storytelling template or creating an interactive map for you to use about anything that has to do with the election cycle this year.
Cool. I'm actually going to show one of those storytelling examples. It's not election related, but it'll give you a sense of how that works. And we can drop some links on how you get started with that challenge. So taking a step back from how our customers use our tools, I was a customer of Mapbox before I joined working at the company. And I always wondered, how did they build it, right? You look at companies that are humongous that have these different developer tools, whether it's Stripe or Twilio or Google, Amazon with AWS-based tools, or Microsoft has been building their developer tools for decades. But mapping has always been an interest of mine, and it's very unique data. So if you look at a map, right, there's a lot of information that you've just kind of probably grown accustomed to interpreting. So in this map, we are seeing about probably 40 to 50 different data layers here without thinking through it too much. So you can see around the center of the map, right, we have the label for Washington, D.C. There's labels for neighborhoods like Penn Quarter, Capitol Hill, Logan Circle. We also have the road network around those, right? So you want to be able to often see streets, highways, but you want to be able to differentiate how those look. All right, you might want to add highway shields, like you can see here. And then, there's, when you really think about it, this is all sitting on top of the land, and there's certain natural features like the National Mall. You can see that big green rectangle in the middle. And then you have the Potomac River. So like, where is all this data coming from? So Mapbox has a number of sources of data. Some are proprietary, and some are open source. Some are purchased from third parties. And we take all of those data sources and combine them to give developers the best, the most flexible data sets to work with. So what you're seeing here is actually our traffic layer. If I flip back, you'll notice that we have some traffic coloring on our road network in this image here. So just from using applications that have maps in them, you might have already kind of intuited, okay, here's where there's green, that means there's no traffic or low traffic, red, heavier traffic, don't want to get stuck there. So Mapbox actually collects anonymized telemetry data in mobile applications and then turns this into an extra piece of tooling that you can use as a developer. At a high level, telemetry data is just a point in time and at a particular time and a particular spot in space, right? So we can represent that with a latitude, a longitude, and a timestamp. Now, this gets anonymized, so we remove any identifiable or like traceable information, and we aggregate this data to a point that it's actually usable. A single sample wouldn't make sense. And we're able to provide a level of, an interface that's both, anonymized and private, but then usable at scale because we have a lot of monthly active users who are using Mapbox maps. Before I started at Mapbox, they tell you, hey, we have X number of monthly active users. And you kind of go, whoa, how's that possible? I guessed way under here. If you want to drop some guesses in the chat real quickly about how many monthly active users touch Mapbox mobile maps, it might surprise you. I'll give it a couple seconds here. Right, as a developer, I just saw like the studio tool for editing, and I knew a couple of the big logos that were using Mapbox, like Washington Post, New York Times, Snapchat. But there are 650 million monthly active users that touch Mapbox maps. And all this interaction and engagement gets kind of folded back into a cycle, kind of like this feedback loop of data that makes the map better. And once the map is better, right, it becomes a better tool for more developers. It gets implemented in more places, and it brings in more users. And it just kind of continues in this little flywheel cycle of creating more data. So when I hear like that many people, all these telemetry samples, like how the heck does the Mapbox team like actually make sense of this and turn it into something useful? So like I mentioned, we aggregate the data or de-anonymize the data, aggregate it, and then turn it into these layers that then can be reviewed for incorporation into our base map. So some of that telemetry data can then be turned into what's known as like our corrections infrastructure. So we're able to start identifying where roads maybe don't exist on our maps today, but perhaps they should. And it gets fed into this, this review loop that has both like AI, ML based reviewing built into it to kind of streamline the process, but also human review for certain aspects. So now that we know like how this kind of comes together, it's probably good to take a step back and say, okay, now what can we do with that? How can we get started with it? So it's best to start with a primer on geospatial data. So even if you haven't heard the term geospatial data, right, it just means a point in space, right, a point on the Earth. And the easiest way to represent that is with a latitude and longitude. So this point right here is in downtown Helsinki. Similarly, so this is what's known as GeoJSON. If you've done modern web or mobile development, you've probably worked with JSON. It's JavaScript object notation, just a file format. But this, what you see here, describes the shape of Colorado. Right? So it's a polygon, and there are 4 points. You can see that there's 5 coordinates in here, just because it has to tell what's the term that I'm looking for, Megan? The spec for GeoJSON requires that you close the polygon. So the 5th, you'll notice the 5th coordinate here is the same as the 1st. So that's a very simple, right, polygon object in GeoJSON. Over here, we were just representing the latitude and longitude with a simple array or list. Actually coding with it, we can do a lot of different things. Some common use cases include visualizing information, navigating the world, or telling stories, right, that are compelling for a certain audience, whether it's a media story, right, or a social media story. Now, visualizing information. We have a couple examples here. Megan will share this presentation, and you'll click on back into these if you want to revisit any of them. But this first example in the presentation visualizes data as just what we call data-driven circles. So when you're visualizing information, right, there has to be some context to it. And if you're looking at everything the same, right, it doesn't really do much for the end user. So you can use what we call data-driven styling to reinforce what you're trying to communicate with your data. So these colors of the circles on this map are rendered differently based on a certain property in the data. So I think this was like a sample of census data, and we added the data. You can see if you come into Mapbox documentation here later, you can add a layer and reference your data source. And based on this census data, we can see that the circle color changes based on a property, ethnicity, and then the ethnicities that were listed in that source data. So this is really powerful, like Megan was saying about that other article, right, where we were looking at disenfranchisement and gerrymandering, situations like that, right? Seeing where you can cross-reference like census data of like population ethnicities, right, with certain like voting trends or access to resources, right? It becomes very powerful, and you can start telling a story very quickly and showing with data in a very visual context that's easy for anyone to interpret and see patterns. So this is one example of when you bring in your data, right? You can add these simple rules. You can quickly start to build a very compelling map. So the next slide, I'll just kind of work my way through these. Is another example of data that you can overlay. So if you have image data, so this could be imagery captured from a drone, right? It could be satellite imagery from somewhere unique, or it could be weather data. So you can see in this image, right? You've probably seen a picture like this before, animated possibly on AccuWeather.com or the Weather Channel, both Mapbox customers, and it's in the Mapbox documentation, we have great examples right here that show you how to do this, line by line. And not only that, so you can see this example just brings in a GIF and defines the coordinates, where to overlay that. So not only can you see the source code for this, but you can actually open these examples in JS Fiddles or CodePens, whatever you're most comfortable with, to start playing around with it and see how you could start building with Mapbox. So those are two examples of how you can visualize information. We talked a little bit about our navigation tools earlier. So there's a great example for getting started with navigation. Oh, that was the wrong one. That navigation referenced the plus and the minus examples here. But we have a plugin that, let's see, oh, maybe it's directions, is that it? Yep. So this is a little plugin that's easy to add to your map if you want to add, A to B directions. So say, I just wanted to get from New York to San Fran. This little tool is, just a couple of lines of code to add to your application, but it gives you this functionality where you can search for places, and that auto completes. You can get driving directions, walking directions, cycling, and then it automatically gets visualized on the map. Now you can also use our navigation services separately. Let me see if. So this in particular, this example here uses what's known as our directions API. Earlier, Megan also referenced our isochrone API. So we have a bunch of these tools in our documentation that let you play around with the APIs to get a sense of how they work. And the isochrone, and if you haven't heard of an isochrone, you've probably seen one. And what it does at a basic level is give you a rough estimation of how long it takes to get from one point outward, how far you can travel. So in this example here, we're making a request to the isochrone API and saying, hey, from this latitude and longitude, how far can I travel within 10 minutes walking? So these are all parameters that you can change. So you could even get multiple increments. So if you wanted to see, hey, from my hotel, what are the nearby coffee shops I could reach, right? Say you were working at a company that focused on travel, right? That's one example use case. I work with some logistics companies who take these isochrones and then check which drivers are inside of them to match a driver to a delivery, right? There's a lot of use cases with these tools. And we definitely recommend you signing up if you haven't already and starting to dive into it. So there's just some quick examples of using our navigation tools. And then finally, telling amazing stories. You can do this in a lot of ways. Megan alluded to our scrolly telling solution that she'll drop a link to in the chat. But here's an example of how Al Jazeera used our maps in a story on Canadian pipeline building. So when you tell a good story, right, you need to set context, whether it's the first few lines of a paragraph or a video or photos. Your user or your end reader, your audience needs context to really understand what you're talking about. And the storytelling solution is a great way to do that. We've had media outlets, nonprofits, and other organizations use this template to create a compelling story that helps really bring the user into where the story is happening. So you can see, sometimes we call it interactive storytelling or scrolly telling, because as you scroll through the story, you can see the map animates in the background. And the solution that we have actually simplifies these interactions down to just editing a simple file with the locations where you need the map to move when.
Quick question in the chat.
Yeah,
Is the Mapbox API only for JavaScript, or is it also available for C++ or other languages?
great question. So we have mapping SDKs for iOS, Android, and JavaScript out of the box. There are bindings that we don't currently manage or maintain, but we've seen teams extrapolate the SDK for, I think there's a React Native wrapper that's out there in the wild open source community. I think there's a C# wrapper. There have been some organizations, it's not our recommendation because it's like not our maintained product, but there have been organizations that have implemented our SDK in other capacities. I think there's a Qt library that's C++ based, if I'm remembering correctly, that utilizes Mapbox. Formally speaking, those aren't our primary SDKs, but it's possible. Any other questions there, Megan, or good to move along here?
Nope, that was it.
Okay, awesome. And this is another simple example of somebody who pulled our solution template for scrolly telling and told a story of places that he was hiking through. So now that we've kind of given, set this stage, like I said, right, given that context for what Mapbox is and what you can do with it, we have a tutorial that we're going to go through. So if you ever need to come back to this tutorial or want to another time, say you miss an instruction or two, we'll have that link in the presentation. But this is what we're getting started with.
We actually have one more question here, Stephen.
Oh, yeah.
Yeah. So what are the most popular open source tools that come out of Mapbox? I remember using something like Fast-Delaney, triangulation, but are there other tools?
So our SDKs are open source. So yeah, iOS, Android, GLJS is our JavaScript library. We also support a library called turf.js that we'll be using in this tutorial. There are also iOS Swift-based and Java-based ports of turf. So turf has some geospatial functions. You'll see in a second, we're going to use a function called buffer inside of the turf library. But this is a simple npm install yarn add if you want to bring in turf for some of the functionality in there. I think those are the main open source libraries that we are publicly maintaining. Yeah, there have been, I know, a number of projects over the years that we've been a part of and either have kind of not been aligned like with the product strategy, but it's those are like the main ones that I think our teams are most active in.
The only other one I can think of is like REST Stereo, or is it REST Stereo Pink?
Oh yeah.
The remote sensing one that's been developed, and it started in Mapbox and then somebody else took it over and it continued to grow. So not something that we maintain, but something that we kind of support adjacent.
Yeah, exactly. Cool. So with that said, we can jump into the tutorial. So in this tutorial, we're going to be using a couple Mapbox services. So we're going to be using the JavaScript library. We're going to be using the tile query API. And then we're also pulling in the turf library. We'll talk a little bit more about what the tile query API is in a second.
And that is sorry, that's the staging link. So I'm just going to post the.
It is.
No worries.
Good eye.
Post the education link in there. So it's labs.education. labs.mapbox.com/education.
Yeah, that's the one. Cool. So this will give you a little sense of how to get started with adding a Mapbox map and how to add some functionality to it. Don't take this too heavy, right? There's a lot of ways that you could extrapolate this for other use cases, and we'll talk through that. So this example in particular, I've created a code pen for, and I've already brought in the HTML and the JavaScript for the project. Megan, have you had a chance to drop that in the chat, or could you do that now?
It's in the chat.
Awesome. Awesome. So if you want, you can pop open that code pen and fork it using the fork button down here in the bottom right, or you can just follow along. If you fork, you might have to create a CodePen account if you don't have one already, but I think you can sign up with GitHub. Then they have some other OAuth integrations, so you can jump into it pretty quickly. So if you fork, that'll create your own copy. You can edit it along. But you'll see in the tutorial that the first step is just initializing the map. So there's a bunch of template HTML here. And this, you'll see, imports the JavaScript, imports the CSS, imports turf. So the CSS, just make sure that the map is formatted correctly visually. There's some minor CSS here at the top. And then there's some more scaffolding just for the body of the HTML. In addition to the HTML, we have some JavaScript that we start off with. So the first thing in the JavaScript you'll see is this huge GeoJSON object for our aliens. So what we're building is a map to discover aliens in Roswell, New Mexico. So like I mentioned before, GeoJSON, if you're familiar with JSON, it's going to look familiar. It has, properties and values, and you can have nested arrays and objects inside of there. And this is just in my code editor to the side, so you can see a little more easily what this data looks like. So inside of our GeoJSON, I'll collapse. You can see you just need to define what type of GeoJSON this is. So this is a feature collection because we have a bunch of geo features in here. And then we have an array of those features. Each one represents an alien or not an alien. You can see it's another GeoJSON object, but they're individual features. And more specifically, they're points. So GeoJSON can be a point, a line, a polygon, multi-line, multi-polygon. But here, we just want points on a map. So each of these aliens is represented by latitude and longitude, and latitude, I think in that case, and some properties. So you can see they have IDs, and there's just a little property on whether or not this is an alien. This could be, any other properties that you want to bring into your visualization. But GeoJSON is the format that JavaScript or Mapbox libraries are going to expect.
Latitude or longitude or longitude or latitude is the great debate of formatting within the geospatial community.
Yeah. If you ever bring your data into like a mapping tool or something and it ends up in like Antarctica and you expect it to be somewhere in the US, you probably have your coordinates flipped. So now that you have a sense of what that data really is, in here, you can see we have a couple lines. If you've forked the code pen that I already created, I dropped an access token in there. So you don't need an access token from your Mapbox account today, but I'll be swapping that out in a few days so it doesn't get abused. But you need to bring in, when we included our JavaScript, imported our JavaScript library up here, that initializes a Mapbox object. So you'll see down here, we add a property to that Mapbox GL object, and it's our access token. And this is just going to be the access token, so you can hit Mapbox's APIs and say, hey, give me this information back. Then we can call the map function on that library to initialize a new map. There's only a few items that you have to pass into this, only a few required properties. You have to specify the container. So this is the HTML element. There's an ID on a div in the HTML that says map. You have to provide a map style. I think this actually might be optional. I think it defaults as a default. But this is the way that you can bring in your custom map styles or some of the out-of-the-box ones. You can center the map around a certain longitude and latitude. You can see our position is near Roswell. And then a zoom level. Zoom levels were a completely new thing to me when I started using Mapbox. And it's just something you kind of get a sense for after using mapping tools for a while. Zoom 0 is going to be if the map is zoomed out as far as possible. And then I think the closest you can get on Mapbox maps is like zoom level 22. And that's, it's really close, basically. And then you'll see in our JavaScript, after we initialize the map, we have this onload function. If you've written in JavaScript before, you've probably come across callback functions. So this is just an event listener. So once our map loads, we're going to do some other things. Spoiler alert here, you have to wait for the map to load before you can add data layers to it. So that's why we work with that. Any questions in the chat so far, Megan?
Nope, no questions, but feel free if, as we're going along, if you have questions, if something's not working the way it's supposed to, just add it to the chat and we can live debug from there.
Cool. So I have two screens also. That's why I'm looking down. You'll see me looking down constantly, but we're gonna go ahead and jump back to our tutorial. So now that we've initialized the map and added the access token, you can just use mine, or if you want, you can drop yours in from your account. We're gonna start to add some layers of our own custom data to the map. And like I mentioned before, this is where things start to get really powerful for how our customers use our tools. You saw how Snapchat brings in their user data, right? And that's all live dynamic data that's constantly changing. In this example, our data is static, right? It just lives in that JSON object, but you could, in theory, right, be pulling this from a database or backend somewhere else. So you'll see here, we added already a layer with a source that refers to that aliens object. So that's our source data that comes in. We define this as a circle layer, and we just have a couple properties for that, how the data is going to be visualized inside of our paint object. We set the color, the radius, and we make them kind of semi-transparent, right? We could change this around if we wanted to, if we were building something else. I'm gonna jump back to the defaults, but you can see quickly how that re-renders based on the rules that you've set up. Okay, so now that I've added that layer, we're gonna go in and add another. And when we actually add this layer, you'll notice that nothing shows up initially. And while we have our original data layer, this is going to be a layer that has an empty GeoJSON collection. You can see our array of features here is empty. And that's because you need to define the layer before you can start adding data to it. And the interaction that we'll add to the map will reveal where our aliens are once you kind of search for them. So when this layer is visualized, when it does have data added to its feature collection, this is going to be a symbol layer. So symbol layers can be text, icons, or both. So say you wanted to display weather data, weather temperatures on a map, right? You could use a symbol layer to represent the degrees for the temperature. Or say you were Snapchat and you wanted to add a layer with people's Bitmojis, right? You could add a symbol layer and use those images as the icons. We're just going to use an icon that comes built into, there's a whole set of icons that come built into Mapbox libraries. And one of those icons is a little rocket. And then 11 is just a reference to the size. And then we want to allow those icons to overlap in case they show up in the same place or near, really close to each other. So for example, you can see here, circles, these circle layers by default allow overlapping here. Similarly, if we zoomed out, we would want to still be able to see where these icons are. I'll pause there for a second. Any questions in the chat, Megan?
Nope.
Okay. Awesome. So we added one layer that's visible because it has a bunch of our alien data inside of it. We have another layer that we can't see yet, but it is there. It just has an empty data set. Finally, we're going to have a layer that visualizes where we're searching on the map for these aliens. So we can see here, again, this won't show up immediately on our map because we have another empty object for our data. You can see our array of features here is empty, but this is going to be a fill layer. So fill layers are good for polygons, things like that, shapes that you want to fill in. And then we just set a color and an opacity. So this one's almost transparent. If it was 0, it would be completely transparent. So we just want it to be light and kind of overlay with our other data. Awesome. So we've initialized our map. We've added our first few data layers, and it's looking good so far. We're going to now add a handler, an event handler for clicks. If you used DOM APIs in JavaScript before, you're probably familiar with like handling click events, passing a callback function. So we're going to copy this function into our map. And in our starter code, Megan, I think this is where I ran into a bug before. This should probably still be registered in the map on load, right? Pretty sure that's where we want to.
I just ran it and it was fine, but
outside of the onload.
Mm-hmm.
Okay, so we're going to add that right here below our map.onload that added the data layers once the map was loaded. So we have this click handler, and it's going to capture. So in the callback function, you get an event, and that event has information, including the longitude and latitude of where the user clicked. So if I pop open the console here, you can see we're getting the lat and long from that event. Now we want to do something a little bit more interesting than just log out the location of where the user is clicking. So we're going to add some more functions in here. So in our alien search, we can pick a place to search, and then we search the area around that. So this function that we're creating here is calculating a radius around the point that the user clicks on. It's going to take in an array that represent the longitude and latitude and a radius, so a distance out from that point. that you want to be able to search around. So we imported our turf library earlier, and turf has a bunch of geospatial functions. The point function just creates a GeoJSON object if you pass in a pair of coordinates. So now that we capture that in create a GeoJSON object from that coordinate pair, we're going to create a buffer around that. So the buffer function from turf creates a certain area around a particular point, line, or polygon. So this is a useful function that I've actually utilized in a number of different ways. For example, I worked with a logistics customer before that wanted to find like rest stops near a route that they were going to travel. So they sent a request to our directions API, got the route that they were going to travel, so a line, and then took a buffer around that line and found rest stops that were close to that line. So there are really creative ways that you can use these geospatial functions. Again, this is a free open source library that you can use on your projects. And there are iOS and Android wrappers. So,
And in this specific tutorial, the interesting part is like very typically a lot of people use a buffer kind of like as the crow flies, but the use case that you might be working with might need to be along a road network, because you might be thinking about how far it is for you to physically travel versus how far is it over a single space and time in a straight line. So that's where like the difference between choosing a buffer or the isochrone would come into play.
Yeah, we talked about that isochrone API, right? Technically, this is a buffer of types, but it's not like a straight line distance, right? There's going to be varying. So if we want to see how far you can drive from a certain point, right? This is not, the distance here is very different from the distance here, right? It's very different from the furthest distance out of this polygon here. In our example, we're just, like Megan said, yep, we're just taking a single point, then calculating the polygon or buffer, encapsulate a certain radius out. Cool. So yeah, again, we took our point, turned it into a GeoJSON object, passed that point into our buffer function from turf. We passed a radius in meters. So this is just the function that we're setting up to calculate the radius, which is this buffered object that we return. So you can confirm that your function, when it's completed, looks like this. It's a pretty simple function, but always good to pull out logic that you might duplicate or use again later. And then we're going to calculate the radius for the event longitude and latitude where the user clicked. We're going to start with a default of 15,000 meters, but you could put anything you want in here to this function that we just created. So we're going to replace our console log and create that radius object there, search radius. Finally, we'll want to update the source data for that search radius inside of our logic. So we have remember we have a few data layers, and each of those layers has a source. So we want to update the search radius source. So we'll see. Once we do that, this will be the effect because we already created that layer. We know how it looks, right? We defined the color, the opacity, and then it's a fill layer, and we got the shape from this function that we just created down here, the make radius function. So, okay, it's very faint. I might make this a little bit darker so that everybody can definitely see it. But now when we're clicking, it's very quickly grabbing those coordinates where the user clicked. It's creating this buffer around that point, and then it's adding that shape back into the source data for this layer. Cool. So it looks like it's working as it should be so far. Any questions in the chat, Megan? Cool. We'll soldier on then. Now we've got to confirm our alien sightings. So this is the part where, you know, these blue locations, right, where aliens were reported, but we actually don't know if there are aliens there. So now we actually have to confirm them. So what we're bringing in here is a function that performs a spatial join. So if you've ever joined data, right, you have to check, right, where there's essentially like overlapping context, right? You might be familiar with like SQL joins or other information that you're just trying to see if this data matches up. The function that we're going to use to make that spatial join, spatial, it's just, you know, geospatial, is to check if a point exists inside of a polygon, right? This is, you can almost think of this as like a, you know, XY axis, you math XY plane, right? And is this point inside of this circle, right? That's all that this function really checks, but turf wraps all that logic up into a nice helper function. And for our function here, we're just passing in that source GeoJSON. We have a filter feature to define like, what is it? Let's see. Right, the buffered radius. So right, here's the data. Here's the extra thing that you need to check it against. And we're checking not only does it exist in that, that feature, but then we're also checking if we have a confirmation, yes, our sighting was an alien. And this, again, this was just back in our source data. If you need a quick refresher, remember these were all of our alien sighting locations, and some of them were true. So, right, this might be other data in a database. It doesn't have to be aliens. You can make these properties in your GeoJSON, whatever you want. But in our case, we're checking for aliens. So now that we have this helper function to check, make that spatial join check, we're going to go back to our click handler. And we're going to check for the features inside of your search buffer that matched with that aliens data set. And we're going to finally update that layer with the rocket icons that we had an empty data set for. Sorry, again, this was in our click handler. So you can see, remember we captured the user's click where it was, latitude and longitude. We created a search radius around that the user was able to search inside of. We visually added that search radius to the map. Next, we checked, okay, now which of those aliens fall inside of this buffer and match this is alien property. And then we're visually updating this, our alien truth layer. And the moment of truth. Okay, so we can see here, we spotted one alien, created that buffer, did a spatial join to see which ones had that property. And this data could be used for all sorts of this use case could be used in all sorts of places, right? Perhaps you're an insurance company and you want to see, hey, within this radius, which houses are at risk of flood, right? So maybe we don't, instead of pointing and clicking and creating a radius, you let the user like draw, right? Actually, that makes me think of if you've ever been on like Zillow or Trulia and use those draw tools to see which houses in a certain area match my price range and have 3 bedrooms and bathrooms, right? These are the same kinds of joins and analysis that you can build and visualize with Mapbox. So I believe that is the end of our tutorial. Yeah.
I always love your examples because they're based in like real customer stories and how they could be used. And I'm just thinking like, oh man, how many Pokemon can I find?
Yeah, no, for real though, right? If like somebody created like a Pokemon Go database with like locations of different stuff, you could create a tool and say, hey, in this place that I'm about to go to this weekend, what's there, right? That match like these Pokemon criteria.
just a big cache of Charizards or Jigglypuffs.
Yeah, exactly. So that is the end of the tutorial. We want to make a plug. So if you're working through this, if you're working through other projects, if you go off and work somewhere else and want to utilize Mapbox, always we recommend Stack Overflow tickets. Reach out to our help at mapbox.com. Also, our support team checks out our Twitter account and watches for outreach there. And we're streaming pretty regularly on Twitch these days. It's most Thursdays. I don't know if it's every single Thursday, but it's been pretty consistent for a while now.
Yeah, it'll at least be every Thursday until the end of the year. We'll have that. Oh.
Yeah.
We have a question. Is that the Brave browser?
Yes. Yeah, I switched over from Chrome, and then I was actually recently debating switching back because I was reading some stuff about it, but I just kind of stuck with it because I have a bunch of stuff that auto-populates and it's too easy. Finally, if you are interested in working at Mapbox at some point, we have offices in DC and San Fran in the US, but as you can imagine, we're mostly remote these days. We also have offices abroad in Tokyo, Beijing, Shanghai, Helsinki, and Minsk, Belarus. Yeah, in case anybody's calling in from there, right? But we have engineering positions. Like I mentioned, I'm on the technical account management team. Megan's on the community team, and we're growing.
Does anybody have any questions about what we went over today or about Mapbox in general? You just want to talk about Pokemon? That's cool too.
Anything you throw at us, we'll take a stab.
Yeah. Just start making some stuff up.
Yeah, no, it's been really interesting, like how many different use cases not only have I seen like since starting at Mapbox, but from like this year, like, you know, COVID response, our team jumped in and helped. Were you involved in the community project, Megan, in New York for COVID tracking and tracing?
I kind of was like on the periphery of that and like all the COVID. We had over 200 inbounds for COVID mapping thus far.
For community, just for community.
Yeah. Just in Mapbox in general, we couponed over 100 of the accounts that came in.
That's awesome. Yeah, lots of different use cases. I've worked with a handful of logistics customers that had to transition to adopt, right? Like when you're organizing drivers nowadays, you can't just like, right, send all the drivers to a particular location, right? You have to think about, okay, do we send the driver that's closest, the driver that has these resources? How do we order that? And it's been really cool to see how you can kind of like take these little building blocks and piece them together to build something that's more than just a map or just a ETA from point A to point B.
So we have 2 questions in the chat. First one is, how can we get more involved with Mapbox community? That's a great question. You can email community@mapbox.com, and oftentimes we are looking for volunteers for different projects. Or if you're working on an education project, or you're working, doing an internship, or working for a nonprofit organization that you think that we could help out in some way, please also get in touch and we can coordinate helping out on those projects. So that's just community@mapbox.com. And the next question is, what are some of the largest advantages that Mapbox as a platform offers over competitors?
Great question. I get to go into sales mode. So when I started at Mapbox, my role was considered pre-sales engineering. So customers were thinking of adopting Mapbox, and I get to show them like, hey, here's how you can build this really cool thing with our tools. So if I jump back for a sec to one of the earlier slides, our maps are, the majority of our map data that you visualize and see is based on what we call vector tiles. So if you've ever loaded a map, I hope this doesn't make me a liar, but recently I think Google's been showing more. So you can see here on Google Maps. So they load it in squares. Those are map tiles. Map tiling is pretty much a standard for map visualizations. But you can see as I zoom in and out, if I zoom in really quickly, the map tiles get like really blurry before new ones load in. Those are what are known as raster tiles. So if you've heard the term raster before, it's probably because it's how pixels are visualized. And so things like JPEGs, PNGs, right, are raster images. They're all pixel based. Mapbox base maps. So if we go back into one of these examples, you'll see that the shapes that are visible and other properties kind of like grow and shrink very dynamically and smoothly. And it's because they're vector-based data. So, they're points in space, and the rendering engine, that's really like some of the magic behind our libraries, knows how to take these points in space and draw them very quickly. It's like 60 frames per second type rendering. So you can see the shape that makes up the road, right? It just grows and shrinks rather than becoming blurry and rendering in a new raster layer. So vector mapping is a big benefit because of both performance, like visual performance, but also the vector tiles are very lightweight. They use, if you want to dig into like the data structure side of things, we use an encoding library called protobufs that you may or may not be familiar with. It's another open source project. Recommend you check it out. But this vector tiling allows for both performant rendering and performant delivery of the map. The SDKs and documentation are just like really easy to get started with and use. A lot of our customers actually grow into like the big customers that I work with day to day. So they might start with one small use case or might start as a small business and then grow their usage. And that's when we engage with them at like a higher level. But it's free to get, because it's free to get started. The documentation is really, it covers like a broad variety of potential like use cases or implementations with examples that you get to see play with the code. And let's see. So yeah, kind of like tools and ecosystem, vector mapping, I think are probably two of the like biggest thing. Like
also the ability to custom design every single piece of the map that we have. So every layer that you're seeing on the map that Stephen was just showing.
Sorry.
No, it's okay. It's okay. It could be, you can change the font at every single zoom level to change. You can change what road networks are on there. You can change the color of the streets, the color of the water. Like everything is totally customizable for your individual use case. And it's amazing. Like we give you all of these layers out of the box. So you're getting all of the work that we put, like this is OSM data, which is one of our base map layers that we're using to be able to see all these POIs and places and boundaries that we're working with. We have our admin boundaries, our satellite imagery that we're hosting from a bunch of different networks, mostly Maxar, I think. But all of that you can get within our core
Yeah.
styles.
Yeah, we have a lot of data providers these days. I think our data team touts something like 130 different data sources that, yeah, between the labels, the shapes of certain administrative boundaries, countries, states, down to in the US congressional districts and counties, things like that. Places of interest, businesses, things like that. So just showing you real quickly here, if you go into Mapbox Studio today and create a new map style, you can get started easily making like big, kind of like sweeping easy changes with components that make it very easy to change stuff at a high level. You can break apart components into like individual layers that they're made up of. So let's say I'm just going to undo that change because I changed my labels all to red here, but I decided, I don't really want that to change all across the map. I just want to change these large place labels, like the ones for countries. I can click into, you can click anywhere on the map and see which data layer or component you're editing. And I can see here, this is the country label. If I toggle over to the layers. So if I want to override just those country labels, I can come in here and change just that information. Like Megan mentioned, right? This can be extrapolated to literally any data layer of the map that you can see. So let's say I didn't want, when we zoom in here, zoom into Paris. Okay, so you can see when you zoom into a map, right, you often get these other features like parks and hospitals, university, campuses, things like that. Let's say that information wasn't relevant for my users. I could remove that by going into, let's see, it's easier just to even click on the map. Move too quickly there. So in Paris, again, we can click on the map to see what layers we want to edit. Okay, that was the land use layer. So I'm actually just going to hide the land use layer by toggling this little eyeball up here. We can see I was able to simply hide that layer. I could delete it if I wanted to, but just for right now, I might want to come back to it. So I'll hide it. Let's say I don't need neighborhoods. I could hide that layer as well. And you can see then there's like the place of interest representation of that data too. So I could hide that as well. Based on what my users should be seeing, right? This is very common. We see like a lot of business intelligence, BI use cases that are visualizing a lot of data. They want to take away the other labels to highlight the data and story that they're trying to tell. But fully customizable, anything you see on the map.
So got a few questions here. How do you quickly render the layers with vector mapping? Is it preloaded?
How do you quickly render the vector layers? So maybe breaking down kind of what's happening. So could be helpful. When I load this page, you'll see.
You start, moving around.
Yeah, if I start moving around and you open up the console in a web Mapbox map, you'll start to see some requests to bring in those map tiles that weren't previously rendered. So there's some smart logic in our library. So you'll see some of those come in. This is that the response is that protobuf format that I mentioned. So you won't be able to read it, but it's encoded and it's compressed. That's data comes back when you move around the map because vector PBF, there we go. You can see this request that came back from Mapbox's APIs. So not only does the SDK wrap the rendering logic, but as part of that, it also does like all the interfacing with Mapbox's mapping APIs. So it sends an API request to Mapbox and says, hey, give me a copy of a Mapbox Streets tile and Mapbox's terrain tile set in vector format. And the SDK knows how to interpret this ID for that tile, and then sends that API request. The tile comes back and says, oh, okay, oh yeah, you want this tile of data. Here's that square and all that data inside of it. And then the SDK has all the logic for visualizing that inside of the HTML in the DOM or on iOS in a component there. Now, you might have also caught, if you were quick to see, that there was a canceled request here. This is actually an example of our SDK identifying that, oh, we've already fetched that vector tile and it's cached locally. So it actually went and grabbed it from the cache instead. Each time you load a map, you'll need to load in those tiles. It might grab them from the cache, might grab them from Mapbox APIs fresh.
This is a question earlier. Would you mind me explaining the differences of the Mapbox platform versus a traditional GIS platform?
Yeah, so a lot of traditional GIS platforms typically have analytics tooling built in. So you might have like functions built into the tool and like a UI out of the box for end users to just like jump in and say, you know, query how many, like, right, it was set up probably with some database connector to some data sources, and somebody can query, you know, how many of my sample data fell within these boundaries, right? Those are the kinds of tooling and answers that GIS software is typically used for, legacy GIS software. Mapbox is kind of like the building blocks that could be used to build something like that, or a million different other things. So Mapbox, right, just provides that mapping component and the APIs and SDKs to make it work, and the flexibility for it to be used in whichever way you want, right? Whether you're the FCC mapping broadband accessibility, T-Mobile or Verizon mapping your 5G coverage, that's debatable, or your Snapchat, right? Visualizing user uploads. So it's a very flexible and customizable platform, whereas GIS software is typically just used to like perform certain analytical functions.
And the next question, I think your IsoCode API is super cool. Thank you. I was interested in how the jagged polygons were rendered. Can you elaborate on how you determine trip duration from a point? Is it based on real-time traffic or road patterns?
It's a great question. So currently it's based on the road network. The team has plans to integrate traffic into it. I can't speak for the product teams, so I'm not gonna go on the recording saying when that is gonna be released. But right now, the Isochron API does support our walking, cycling, and driving routing profiles. So let's say, you know, you're Strava and you have this biking app, right? And you want to show where all the places somebody can bike to within an hour, right? You could easily send that coordinate pair to Mapbox and we'll give back these polygons. How the distances are actually determined is based, I hate to say it, but it's like, you know, proprietary routing algorithms. I mentioned this before. If you're interested in this space, there's some open source libraries for routing that can give you, you know, a start to understanding how might you traverse a road network, right? It's all like graph theory, graph traversal, and determining based on certain weightings in the road network, you know, what are the max speeds along certain highways or minor roads. Our proprietary navigation engine can determine the furthest point out, or roughly the furthest point out that somebody could reach all around a certain point. I don't know how much more detail I can give based on what I'm allowed to say and like what you're looking for, but I hope that helps.
Yeah, network analysis is a really interesting and like common geospatial problem. and the idea of like the constraints that you put on it, whether it's the miles per hour or the type of car that you're driving, or even like the elevation that you're traversing, are all things that you have to think about when you're building one of these models. So great question. check out the API. How are your tools for game engines?
The tools are pretty cool. So I haven't, game development is like one of those things that I'm always like, oh, one weekend I'll kind of jump into it. And I've tested out some JavaScript libraries for like 2D development. But we've seen some pretty cool games built with it. City Builder is one that I've actually played a little bit here and there. Actually, I haven't picked it up in a few months, so I'm really hoping that's the right name. And what they do is, yeah. Oh, city building games. I've got to find it, but the basic idea for this one is a little, I'll say like a little like Farmville-ish. Maybe that's dating myself. But you know, all these games where you like you build your you build on like your land and you upgrade all the stuff that you build on your land, and every so often, right, you get rewards from that stuff. And so they actually used our mapping tech to determine like how they lay out around a person's area. And based on like the road network, you can like buy up land nearby to where you live. And they have other approaches for like how they segment that out, but they use our base map as kind of like the canvas for that. So like you can build houses, and then you can build like a sawmill nearby, and it gives you 5 coins every 3 hours. We've seen some implementations kind of along the lines of Pokemon Go, where if you walk around, right, you can see your user location, and you can see other virtual things that live in the real world. I recommend you check out our Unity SDK. We actually just announced that, Megan, it's Unreal Engine that just released an integration, right?
I think so.
This just went out on the blog like a week or 2 ago. But for similar kind of use case, when you want to bring in some core like foundational map data into your game, like I said before, right, it's all about that, providing that proper context for your end users or customers, whether you're telling a story like the Washington Post, or just want to make a more immersive experience in a game.
Yeah, it was Unreal Engine. So.
Yeah, so there was recently a Unreal Engine update that integrated like a Mapbox plugin.
And now this isn't a game that's been published, but I was working with students from another university a couple of years ago, and they were using our Vision SDK to build a driving gaming app. The idea would be it would be for driver's ed, and they were using our Vision SDK to kind of figure out how you could tell if somebody was obeying traffic laws, like figuring out if they were stopping at the stop sign at the right time, if they were going over the speed limit, and trying to like gamify learning how to drive as you're driving, which was really cool.
That is cool.
Yeah.
Yeah. Okay. So it looks like the Unreal Engine is for Unreal Engine for auto. So I think they're working with like a lot of automakers like we are. And these days, right, people expect really clean rendering. They expect cool 3D visualizations, and the visualizations that they do, right, in Unity, where you can bring in like a Rocket League car, right, as to visualize your car on one side, can look very branded and right in line with the mapping experience when you use Mapbox, because of that customization that Megan called out.
So we got 2 more questions. I think these are the last 2 because we're at time. So one of them, what is your favorite part about what you do at Mapbox?
Yeah. Wow, there's a lot. Gosh, it's one of those things like I can't pick like just one thing. I do really like the people that we work with, like internally. Like Mapboxers are some of like the coolest people. Definitely the best company I've worked with, best group of people I've gotten to work with. Getting to work with the community team with Megan and other folks over there on projects is like super awesome that I can just like spend time and get paid for it to just literally just help people and organizations. Is definitely a huge benefit. I get to work with some pretty big customers like AccuWeather. I work with some cool government customers and some logistics customers that I can't say, but it's like really cool use cases because when somebody's using your tools at a certain scale, it's like impacting so many people's daily lives, right? The work that you're doing. Like we mentioned, the SDKs are touched by 650 million people each month. And that's a lot of impact. That's a really broad reach. So that's probably been, I'd say, the people that I get to work with and both internally and externally is like the best thing about it.
I'd say very similarly, like definitely the people have been so fun, and that's the hardest part about COVID right now is not being able to see everybody every day and play foosball during my break time. But also I was working in academia before this. So the scope of my projects were really specific and quite narrow that I'd be working on for years. And coming to Mapbox is just like so much fun because I work on the community team and now I feel like I get to work on so many impactful projects at once rather than just being hyper focused on this one specific area. And for me, that's been so exciting because you also like are moving at this lightning fast pace and seeing how the mapping industry is growing and changing at this lightning fast. Even as we're like moving into this year, the changes that we've seen internally of our product because of COVID and the way that we're thinking about mapping and collecting data and stuff like this has been fascinating to see how many people are interested and the interest in mapping is growing. Yeah, it's fascinating. I love nerding out on it every day, and I love working out with people who really like getting into the weeds of some very specific geospatial problems. So our last question is, what are your thoughts on Cesium in the game stroke OSM terrain generation space?
Sorry, one more time. Cesium and what?
Cesium in the game / OSM terrain generation space.
Gonna be honest, I'm not gonna have a strong take here because I'm not familiar with. I haven't kept up. I've come across Cesium JS, but I don't have too much more context to go off of, unfortunately. Anybody who's contributing, I think they've been picking up contributions to OSM recently, if I'm remembering correctly. You always love to see more companies adopting and contributing back to OpenStreetMap. We mentioned it a few times. If you haven't heard of it or aren't familiar with it, OpenStreetMap is one of our main data providers or data sources. And you can kind of think of it like a Wikipedia for mapping that's much better moderated. So if people want to go in and recommend an update to the map, they can, and then it gets reviewed. And then Mapbox has another review process that's AI assisted and human reviewed. But we've seen companies like Microsoft, Facebook, Apple really start contributing back to it in a real way. That's really awesome. And it's like an open source data project, which is really cool.
Yeah, I love it. It's one of those things that, again, like the map is always changing. Roads are being built and destroyed every single day. And OSM is a great way to contribute to that work, especially if if there's a humanitarian effort going on, such as like a hurricane or an earthquake somewhere. If you want to get involved in that community, Hot OSM is a great way to get involved, helping to put points on the map.
Yeah, if you're ever looking for like an easy way to give back and feel good about yourself while just clicking around a screen, like going in and updating OSM is an awesome way to get involved. Hot OSM is the organization that Megan just mentioned. Cool.
Well, thank
Cool.
you.
Oh, I think you
UCM.
only sent it to the panelists.
Oh, yep.
Yep.
I'll send again. Cool. Thanks, Adam. Yeah, thanks, Adam and Alvin, and everyone else for having us. This was really fun. Thanks for all the questions, engagement. Again, if you want to reach out to us, you can reach me just at steven@mapbox.com. Pretty much everywhere else at SE Geissens, and we'll make sure that you all also get this presentation and the links that we shared.
Yeah. Again, thank you so much, Stefan and Megan. We really appreciate it. And just as a reminder to all attendees, if there was any part you missed, or if you missed the code pen, we are posting a recording of this onto the ACM YouTube. So feel free to review it. Feel free to share it with your friends. I think there's a lot of great things here. And I know a lot of the participants kind of popped in a bit late. So definitely really excited to see, what kind of things you go out and build with these tools we've shown today. Thank you all.
Thank you all.
Thanks. See ya.
All right. Bye-bye.
Thank you.